Hello and welcome to this SPSS one-on-one series with the audio analytics. Today we look at the paired samples t-test, which you can use to compare differences between two measurements that were made on the same participants. As usual, we use a dataset that comes pre-installed with SPSS that you can access on your computer and follow through the steps as we are running them. To access today's dataset we shall use, simply go to File, Open Data, locate the installation folder for SPSS, usually under this PC, and look for local disk C, the partition with Windows. Go to Program Files, select IBM, open SPSS, open Statistics. You will see a number corresponding to the version of SPSS that you're using. Go ahead and open it, and then locate the samples folder, then choose your language. Today we are using a dataset called test scores, which you can access by using the horizontal scroll bar to the right. Select the dataset called test scores and then open. So our focus today is going to be on two variables, pre-test and post-test. These participants, they were given an assessment set before a training, and their marks are recorded as a numerical variable. Then after the training, they were subjected to a post-test, and their marks are also recorded. So the question we are asking ourselves, is there a difference in the mean scores at pre-test versus the mean scores at post-test? The null hypothesis states that the mean pre-test scores are equal to the mean post-test scores. But the alternative says the mean pre-test scores are not the same as the mean post-test scores. So let's run a paired samples t-test to see whether there are significant differences. To run the paired samples t-test, simply go to Analyze, go to Compare Means, and go to Paired samples t-test. So in this dialog box, you can see we have paired variables. We are going to pick the pre-test, grab it and release it under variable 1. Then we have the post-test, which we shall grab and put under variable 2. We are telling SPSS that yes, this pre-test and post-test have values for the same participants. Once everything is set, simply click on OK. I'll expand this. First, you will have the summary statistics. In pair 1, you have the pre-test and post-test. Under pre-test, the mean was 54.9, but in post-test, it kind of increased to 67.1. The numbers are the same in both pre-test and post-test, so whoever did the pre-test did the post-test. We have the standard deviations and standard errors. Here we have the paired samples t-test results, where we see that the mean difference between these 54.96 and 67 is 12.146, and the negative is simply indicating the direction of what is being subtracted from the other. So here it is pre-test minus post-test, we have that. And here we have the standard deviation, the error of the mean, their confidence intervals, but most importantly, we are looking at the p-value. Here the p-value is less than 0.05, the usual significance level. So we would say there are statistically significant differences between the post-test results and the pre-test results. The mean test scores in the post-test were significantly higher than the mean test scores in the pre-test. And there I would confidently say my training improved the performance. Next, I show you how you would present these results for your research. So you would simply present your results as follows. A paired samples t-test was conducted to compare pre-test and post-test scores. Results showed that the mean post-test scores the value is 67.1, standard deviation of 13.9. You can see here the mean is here, then the standard deviation was significantly higher than the pretest score. The pretest score, the mean is 54.9, and then the standard deviation was 13.6 here. Then you quote the T at degrees of freedom. This, you can see the degrees of freedom for the t-test. This one here, 2132, is this, which is a negative. Sorry, here the p-value was less than, and just put less than 0.05. This indicates that the training had a significant effect on student performance. As simple as that. So today we've looked at the paired samples t-test, how to run it, how to interpret it, and how to present your results for your research. Next we look at the one-way ANOVA or one-way analysis of variance. Today we were comparing two groups. However, if the groups we are comparing are more than 2, are 3 and above, we cannot use the t-test. So we have to use the one-way ANOVA. So next we look at the one-way ANOVA, the assumptions, how to run it, interpret, and present your findings. If you have any comments, simply drop it in the comment section and we shall respond to it as soon as we can. Like, subscribe to our channel so that you do not miss out any of the episodes. See you in the next video.